So we started this topic yesterday, the particulate nature of the matter, and this is topic one according to the syllabus. A quick revision what we discussed yesterday. So we started with the concept of the matter and the properties of solid, liquid, and gas. Then we compare the type of the motion in the within this particle of solid, liquid, and gas, the force of attraction between the particles. Then the kinetic molecular theory or kinetic particle theory, and discuss how what we call when a solid change to liquid, liquid change to gas, or a gas change to solid, or a gas change to liquid. This is what we have discussed yesterday. This is a topic for today. Describe the qualitatively the pressure and the temperature. The term qualitative means you will not use any formula here, you just have to explain the idea. If it is described quantitative, it means you have to use a formula to explain the idea, but qualitative is just about the theory. So how we explain the pressure and the temperature of a gas. So what is the meaning of the pressure of the gas? The term pressure of a gas, it means it is number of the molecules colliding with the wall of container. So how many particles are hitting the container, or the number of the particles which are hitting the container, that decide the pressure of the gas. So example, if we have two containers and they have different number of the particles in the same volume, in which container the gas will exert more pressure, container A or container B? You can use a chat to state the answer. The question is, in which container the gas will exert more pressure, container A or B? So in container B, the gas molecules will exert more pressure. Why the gas molecule will exert more pressure? Because there are more particles, so greater the number of the particle, greater the collision between the particle as well as with the wall of the container. So more particles will hit the wall of a container, and in A, few particles will hit the wall of the container. That's why B will exert high pressure and A will exert low pressure. And how we define the temperature of the gas? The temperature is refers to speed of gas molecules. The speed of the gas molecule relate the temperature. So if we increase the temperature, the molecules will have more energy and these molecules will move faster. So example, if we have two containers filled with equal number of gas molecules, and it's at different temperature. Like example, this one is at say 30 degrees centigrade and the other one is at 60 degrees centigrade. In which container the molecules are moving faster, A or B? Which container the molecules are moving faster? So B, or at 60 the molecules are moving faster because speed and temperature are directly proportional. So as we increase the temperature, the speed at which the molecules are moving will increase. So P is the right answer. And if the question is in which container there is a high pressure, you have equal number of the particles, but the two gases are at different temperature. The two containers are at different temperature. Which container there is a high pressure? A or B? Yeah, that's right. B is the right answer for high pressure as well. What is the reason why B is the right answer? Because when the molecules are moving faster at once, greater number, like example, out of 4 molecules, maybe 3 molecules will hit the wall. But this one, the molecules are moving slower. So maybe at once only 2 molecules are able to collide with the wall of container. So when we increase the temperature, if we keep the volume same, the pressure of the gas will also increase. Is it clear, this concept of pressure and temperature? Any doubt or a question? You can use a mic or you can use a chat if you have any question or doubt. So moving on to the next part. At the top of the slide, you will always find the objective, like the syllabus objective. This is from the syllabus only. So what is the objective of this part? So you should show an understanding of a random motion of the particle. What is a random motion of the particle? How we explain the random motion? A motion which is not having a specific direction, we call that motion as a random motion. Example, if this is a particle, it continuously changes its direction. So there is no specific direction in which this particle is moving. It is changing its direction many times. So what we call this motion? We call this motion as a random motion, and this random motion is having a specific name. This is also known as a Brownian motion. So random or zigzag motion of the molecule is refers to the Brownian motion. If there is another particle and it is moving towards right hand side, is it a random motion? This one on the right hand side. So it is not a random motion. Why it is not a random motion? Because it's in a specific direction, it is towards right hand side. Same thing, if I draw a particle and shows the motion, is it a random motion on the left hand side? So yes, it is a random motion. Why it is a random motion? Because the particle is not moving in a specific direction, it changes the direction. That's why we call that as random motion. But what causes a random motion of the particle? Like maybe in everyday life you may have experienced this. For example, you will find when a sunlight is passing through a narrow passage or entering a window through a narrow passage, you will find the dust particles are suspended in air and they are continuously moving and they are changing the direction. So that motion is known as the random motion. But what is the reason why the dust particles are moving in this manner or in this way? So basically, we are able to see the dust particle. Dust particles are heavy particles. So example, if this is a dust particle, so this dust particle is surrounded by millions or trillions of air particles, air molecules. But because the air molecules are so small, we are not able to see these air particles. So what happened when these air molecules colliding with the dust particle? So what it caused? It caused a random motion or a random movement. So this dust particle, like some molecules are hitting from right, some are moving hitting towards left from left, some are from top and some are from bottom. So particles are continuously hitting. When the air molecules are continuously hitting the dust particle, this caused the dust particle to change the direction many times. Like as this dust particle move in this way, so this is a new position of the dust particle. Then at this position, further air molecules hit the dust particle. So when these air molecules hit the dust particle, this dust particle will move in another direction. So as it is changing its direction many times, what we call this motion, we call this motion as a Brownian motion. So Brownian motion is simply a random or a zigzag motion of the molecule. And why the particle undergo a Brownian motion? Because the smaller particles are hitting the heavy particle, which cause the random motion of these heavy particles. So as you can see here, the black dots are representing the air molecules and the yellow spot is representing a dust or a smoke particle. So you will see as these air molecules are continuously hitting the dust particle, these air molecules cause a random motion or a random movement of this dust particle, which we call as a Brownian motion. Is it clear? The concept of the Brownian motion? Any doubt? So the random and the zigzag motion of the molecule is simply refers to Brownian motion. But how we can observe this Brownian motion, the experimental setup, because the objective, this is a syllabus objective, show an understanding of the random motion of a particle in suspension like as a Brownian motion, evidence of particle, atom, molecule and ion model for matter. Basically this Brownian motion confirmed that matter consists of the particle. That's why like here we have air contained particles and these particles are continuously hitting the dust particle and it causes a random motion. And you should be able to describe and explain the Brownian motion in terms of a random molecular bombardment, like explain the idea that why this dust particle move randomly. So what should be your answer if a question is give reason why the dust particle is moving randomly or undergo a Brownian motion? So the points which we include, first thing we'll mention the heavy dust particles colliding with lighter air molecules. The air molecules exert force on dust particle, cause random motion, or we can also say a Brownian motion. Then how practically how we can observe this Brownian motion? So this is the experimental setup to observe the Brownian motion. As you can see here, we have a microscope. This is an eyepiece, and here we have objective. What we have here, we have a glass, and inside this glass we have a smoke particle. We can take a smoke particle or we can take a dust particle. What is the purpose of this lamp? The purpose of the lamp and this lens is to make this smoke particle visible, because if it is dark it will not be visible to us. So when the light is passing through, then these smoke particle will be visible to us. And when we focus on any one of the smoke particle, what we will observe, we'll observe a same Brownian motion. I'm drawing here. So if this was a smoke particle, what we observe when we are looking through the microscope, we'll observe that it is continuously changing the direction. And again, why this smoke particle is continuously changing the direction? The same answer, the same reason, that because this smoke particle is continuously colliding with the air molecules, and these air molecules cause a random motion of this smoke particle. Is it clear, the experimental setup, that how we can observe the Brownian motion? What is a convex lens? The convex lens, there are two types of lenses, convex and concave. The purpose of the convex lens is to converge the light, focus, like what it normally do. If this is a convex lens, so when the parallel light rays or light rays are there, this convex lens converts the light rays to one point. So when it converts the light rays to one point, that point will be visible or that point will be brighter. So in this region, if we observe any smoke particle, that smoke particle will be visible to us. What is the purpose of the smoke? You can use a smoke particle or a dust particle, because example, if you was having a glass here, in this glass you trap air, but this, because air particles are not visible, you cannot see with the naked eye, that's why you cannot observe a Brownian motion. So what you do, you can add a dust particle or you can add a smoke particle. So when you add these smoke particles and you will observe this smoke particle, so what you will see that this smoke particle is continuously changing the direction. So the main purpose of the smoke particle is to make like smoke particles are visible particles, so we can see them. If there was only air particle, we cannot see air particles. Even the air particles which are around the smoke particles, we cannot see them, because air particles are not visible with the naked eye. So this experimental setup is based on the idea that because the smoke particles are visible to us, so when the light is passing through, we can see the smoke particle undergo a random motion. So as they undergo a random motion, we call that as a Brownian motion. Is it clear, the experimental setup? And when you are asking a question, it is better your question should be visible to everyone, so that everyone understand what is your question and they learn from your question as well. So if you are asking a question, it's better keep your question visible to everyone. Then the last part of this topic one, that is diffusion. So you should be able to describe and explain the concept of a diffusion. What is a diffusion? Diffusion means actually intermingling of a substance from natural movement of the particle or movement of the molecule from region of higher concentration. You have learned this definition, that it's a movement of the molecules from region of high concentration to a region of lower concentration, we call this as diffusion. So in the beginning, at the start, what you will see, the particles are closer. So when the particles are closer, that was a region of the high concentration. Initially, when you observe this, you will see that the particles are closer. That region is refers to a region of high concentration. As the particles move in this region, initially we were having more particles in a unit volume, so we called this is a region of high concentration. So as these particles collide with each other, they move from region of higher concentration to a region of lower concentration. Lower concentration means where the number of the particles are less or few particles are there. We call lower concentration. So as these particles are moving from high concentration to a region of low concentration, what we call this process? We call this process as diffusion. An everyday example, like example, in a kitchen, if someone is cooking a food, you can smell the food after some time. Even if you are using a perfume, the smell of the perfume spread throughout the room. So why it is spread throughout the room? Because of the process of diffusion. If this was a bottle of perfume which is having a liquid and the gas, both phases are there. So when you spray this perfume, these droplets will come out, and in this region you have a higher concentration of the particle. But what happens as these particles move from a region of higher concentration to a region of lower concentration, so if another person is there at position A, he can smell this perfume, and that is due to a process called diffusion. So net or resultant movement from a region of higher concentration to lower concentration is simply known as diffusion. And diffusion can happen or can occur. Diffusion can happen in liquids and gases, but it cannot happen in solids. What is the reason why a diffusion cannot take place or diffusion cannot occur in a solid? Because in a solid, as we discussed, the particles are tightly packed together. So within a solid, the diffusion cannot occur. Why within a solid diffusion cannot occur? Because the solid, the particles are tightly packed together, so there's lot of attraction between the particle. By themselves, these particles cannot go out or move away. That's why in solid, you don't find a process of diffusion. It can occur only in liquids or gases. Is it clear, the concept of diffusion? But how a dissolving can happen? Basically, how a process of dissolving can occur. Example, if you take a container, and you fill this container with, example, you take a container and you fill this container with a liquid, and you are adding, example, crystal of salt. Say this is a crystal, and it is having a regular arrangement, and these are the particles of liquid. There are spaces between the particle, but not too much as compared to that of gas. The particles are closer, and this was a solid crystal. When we add this solid crystal to a liquid, what we observe, like this is a solid crystal we add to a liquid. Within the solid, diffusion cannot occur, but within liquid and gases, the diffusion can occur. So first what happened, because the solid is added to a liquid, so particles which are inside the solid, now these particles can move as the dissolving occur. So as these particles move away from each other, so there are two processes which occur here. Number one is dissolving, and after some time the particles of the solid spread out within the liquid. When these particles of a solid spread out within the liquid, what we call this, we call that as diffusion. So two processes are happening here. Number one is dissolving. What happened in a dissolving? When we add a solid crystal to a liquid, the particles of a solid or within the solid, because they are in now in the liquid, so they tend to move away from each other, because the liquid molecules are attracting the solid particles, so their molecules are moving away from each other. As these molecules move away, we call that process as dissolving, because when you add a sugar or a salt to water, you call this process as dissolving. And when the dissolving occur, now what happened, the particle which were there originally in a solid, they move from region of higher concentration to a region of lower concentration. What we call that as diffusion. So two processes occur. First is dissolving, and the second one is diffusion, when you add a solid crystal to a liquid. Is it clear? So basically what happened, yeah, I mentioned diffusion does not occur within the solid. But when a solid is added to a liquid, directly diffusion will not occur. First, what will happen? The solid will dissolve, and then there is a diffusion. So example, if you add, say you have only a solid. Example, this is a crystal. Say this is a solid crystal. So diffusion does not happen or occur within the solid. So what does it mean? Like if you have only solid, you don't find diffusion. But if you add this solid to a liquid, so if you have a container which is filled with a liquid, these are the liquid molecules are there. But when you add this solid to a liquid, then what happened? The particles of a solid, first they spread out, first they move away from each other, and after moving away from each other, they move from a region of higher concentration to a region of lower concentration. Then we call diffusion happen. So when a salt is added to water, we don't say directly diffusion happen. First is dissolving and the second is diffusion. First it dissolves and later diffuse. So both things happen. First is dissolving, then diffusion. But for example, if you have gas only, a container which is filled with a gas, say a room which is filled with air. So in this room, air is present, and you use a spray here, like example, a perfume or a deodorant or a body spray. So when you use this spray here, so directly these particles, the liquid and the gas particle, directly they move from a region of higher concentration to a region of lower concentration. So we only say that here diffusion occur. But when a solid is added to a liquid, first the solid dissolve and then diffusion occur throughout the liquid. Is it clear the difference between the two? To everyone? And same thing, if you fill a container with particle, wouldn't it be? No, smoke is actually when you burn something, a black soot which is produced, that is called a smoke. If you fill the container with particle, so it will not turn into smoke. It depends on what type of particles you are adding to a container. Same way, diffusion depends on the molecular mass as well. What is the meaning of molecular mass? We discussed yesterday that we calculated the molecular mass of different gases. Example, you have a container here, and this container is having two gases. One is ammonia NH3, another one is carbon dioxide. What is the molecular mass? The mass of the molecule is called a molecular mass. The mass of nitrogen is 14. We'll use the periodic table, you will find it's 14. Mass of hydrogen is 1 and mass of carbon is 12. Mass of oxygen is 16. So how we can work out or how we'll know the mass of ammonia or NH3, the molecular mass basically. So nitrogen, there is one nitrogen, so mass of one nitrogen is 14 plus hydrogen, the mass of hydrogen is 1, and how many hydrogen atoms are there in this compound? 3. So 14 plus 1 into 3, that total mass will be 17. So what is the mass of ammonia? That is 17. What about carbon dioxide? Carbon is 12. One carbon is there, that's why 12 plus. Oxygen mass is 16. And how many oxygen atoms are there in this compound? 2. So it should be multiplied by 2. So 16 times 2, 32 times plus 12, that will make 44. So total mass of carbon dioxide is 44. So now the question is, which gas will move faster or diffuse faster? So which gas here will move faster, NH3 or CO2? So when you find the molecular mass of NH3, excuse me, it is 17, and for carbon dioxide it is 44. So carbon dioxide is a lighter gas, and ammonia is a lighter gas and carbon dioxide is a heavy gas. So which gas will diffuse faster? In this case, ammonia will diffuse faster and carbon dioxide will move slower. So lighter particles can diffuse faster or move easily as compared to that of heavy particles. Is it clear? The molecular mass, how to get or find the molecular mass? That just add the mass of individual atoms multiplied by number of atoms, you'll get the molecular mass of that compound. So another example related to diffusion, if you add a drop, if both gases have the same mass, they will diffuse at the same rate. The lighter one will diffuse faster. Yes, it is, the mass is having unit, it is called gram per mole. The unit of the mass for the gases is called gram per mole, G/mol. That's a unit for mass. A simple example of a diffusion, example, you fill the beaker with water and you add a drop of ink. So when you add a drop of ink, what you will observe? You'll observe that the particles will spread out, and as they spread out, they're in the region of high concentration and they move to a region of lower concentration. Eventually, you will have a uniform distribution of the particle. When you have a uniform distribution of the particle, that the solution will appear as same color. If you have a higher concentration of the particle in one region, you can see in this region we have a high concentration of particle. That's why you see a dark color. But once we have a uniform distribution of the particles are uniformly spread out or distributed, you will have a same color throughout the mixture. This is also explaining the idea, like you have a glass which is filled with water and you add a sample or a drop of ink or a color or a dye, you will find that the particles spread out and it diffuses. But on the left hand side, yeah, if all the particle in the one region we call high concentration. But you, on the left hand side, you can see the part, it is diffusing faster as compared to right hand side. So what could be a reason? The reason might be a temperature. This might be at high temperature and this might be at low temperature. So high temperature particles move faster, whereas in low temperature the particles will move slower. So diffusion depends on the mass of the particle as well as the temperature of the substance. Less than a minute left, so I'll share another link with you and continue the discussion.